Hi guys, my name is Chanchai from Chulalongkorn University. What I'm going to share with you today is about doing research based on my own experience. Before I'm going to the detail, I would like to tell you the definitions of research in my point of view. If you look at the words research, there are two syllables. Re, which means do it again, and search, means findings or looking for something. When we lost something, we will do searching to find it. Or when we get a question, we will do searching to find the answer. And that answer will lead to the next questions. And that next questions, we would need to do the researching, do the searchings again to find the next answer. And that next answer will lead to another questions and do again searching to find another answers. And we will do this process over and over again until we get a big piles of answers. So that is the process of research. So research is actually the process to synthesize a new knowledge using scientific method or scientific approach. And once you get the new knowledge and your discovery, you need to tell that to other people. And that process called publication. You need to have a writing skill, make a paper or manuscript to get published. And the process from the beginnings of doing a research until you get the final end to get your data published, it's not that easy, but it's not too difficult to do it. So based on my own research experience, more than 10 years, I summarize or categorize the level or the step of going through from the beginning to the end into 5 steps. And the first step is you need to find your area of interest or the topic that you want to work on. And then you need to explore what is already known in that area because research is about finding the new things. So before getting a new thing, you need to define what is it you have, what is it already known, and define the spot of unknown spot that you want to explore. After that, you need to talk a lot, discuss a lot with your professor or your supervisors about creating or arguing the good research questions. You need to formulate the working hypothesis, and then together with your professor, you design your experiments to prove it. You have to do the laboratory experiment to prove it. After that, you get the data, the result, or the finding, summarize it, analyze it, and then you get the new findings. Be prepared to publish the data. So it's going to be like climbing up the mountain. You want to go to the top of the mountain. That means you want to publish the data, but you need to start it from the bottoms. So you need to start it from finding the areas and then go step by step until you go to the top of the mountain. So in this talk, I would like to walk you through all of these 5 steps based on my own experience. First, let's talk about finding the area of your interest. So you may have a questions, what topic or which topic should I jump in? So based on my experience, I classify the topics, the research topic into three kinds of topics. The first one is the hard topic or fancy topic like gene editing. If you like something like that, you go for the very current problem now is about COVID-19. If you like that, you jump on that topics. The second class of topic is the topic that you feel connected or comfortable with. Because I usually they got a lot of students that come to me or approach me like my relative or my dad died of that cancer, so I really want to explore more in this field. Really want to do a research on cancer, something like that. If you have some kind of this experience, yes, you can choose this kind of topics. And the last topic type or class of topic is the topic that your friends or your professor, your supervisors that you know is working on. That's the that's sort of a kind of topic. For me, in my case, I choose the topic because I know the professor working on that field, and then they jump it. But the point is, what I want to say is really not about the topic that you're going to choose. It doesn't matter it's going to be a hot topic or the topic that you're very connected with or the topic of your professors. You're going to learn the same thing. You're going to learn the scientific way to find the answer. You can learn how to think scientifically. So you learn the process, actually, the process to get the answers. So that's why I think topic is not that very important. The more important one is about asking yourself how much desire, how much you need to do it, the research. If your answer is yes, and then you just go for it. Don't worry about much the topic that you're going to do, even the idea. If you don't have a very good idea yet, you just don't worry about it. I like the speech by Mark Zuckerberg in 2017 when he got a doctorate degree from Harvard University. He said in his speech that ideas don't come out fully formed. They only become clear as you work on them. So you just have to get started. So the key is you have to do it. You start it now. If you have an answer in your mind that you want to do a research, you just go for it. Ask professor or people you know, and then go for it. You need to do it, failed it, and then you get learn. You learn it. And most people say, yeah, I have heard a lot. People say, if you want to start something, start with something that you love, you like, you want. But actually, in my point of view, and also based on my experience, it's rather to start with what you have. What is it available to you? I like the song, one sentence in the song of Stephen Stills. It's very old song. It said like, if you cannot live with the one you love the one you live with. Yeah, actually, this is true in reality. So because we cannot have everything we want, we cannot get everything we love, but you can live or be happy with what we have. So, for example, in my case, do you know the worm? Yeah, the worm is look disgusting to me. It's very to me it's very nasty animal. I don't want to touch it. I don't want to work on it. But I know the worm researcher. They really like it. They see the very beautiful size of it, very fascinating. They love it so much. They take care of it. They do lots of research on it. They got a new discovery on worms. So that made me realize that actually everything in this world has a very beauty and fascinating size. If you see things ugly, that means you don't look at it closely enough. So just look at it, every angles of it, and then you will see the beauty side, the fascinating sides of that thing. And finally, you will fall in love with it and upset. It just, yeah, like in my case, actually at the beginning, I want to work on cancer, but I don't know much people on cancer at that time. And then I found a professor that working on kidney stone disease. So I jumped in and enjoyed the group. And now I realize that there's a lot of things that we don't know about kidney stone disease. So now I very fall in love with. I really want to stick on this kidney stone disease until now. Yeah, I I I, I want to know more, and I want to discover the new thing that can treat, can diagnose the kidney stone disease. Once you get the topics or design, you have decided what area of, of investigation that you want to go in, you need to explore that area more. Because, like I say, we don't do research on what that's already known. We want to identify or discover the new thing, the new knowledge. So before that, you need to know what is the current knowledge, what is the body of knowledge that people knows now, and then identify the unknown spot, and then pick one spot That is where do you want to explore. It actually is like doing a research. We want to find a new piece of knowledge, like a jigsaw. We need to make that jigsaw to put in the big puzzles. After you got that literature review ready, and then you talk with your supervisor, your professor, yet how to create a very good research questions. It is very important because you need to ask the right thing, and it's very important thing too. There's two components in research question. Is the first thing, it has to be originality, which means there's no one else or no other people have asked this before. You have to be the first one to ask that very smart questions, and that question have merit or has benefit to mankind or have application, not just about a question. After you got a question, and then you need to make hypothesis. Hypothesis means the answer that you think it would be, or the expecting answers or anticipated answers to your research questions. For example, if you think gene X, you ask gene X should be, or maybe the tumor suppressor genes in cancers. So you have, after you do a literature review, and then you have a very good confidence or strong confidence that gene X could have a suppressive role in tumor or bladder cancer carcinogenesis. This is the hypothesis. Once you get a hypothesis, you're expecting that answer, you have to decide what to do or what to measure to answer that question or to confirm your hypothesis. And that what to do list is objective. You need to have objective list all of them that you need to do or measure to get to your answers of that research question. For example, if you want to identify gene X, the function of gene X, you have to investigate the expression of gene X, yeah, mRNA and protein level, and also you need to do some kind of knockout or mutation of that gene and see what is the role after you loss of that genes in that carcinogenic models, for example. And you get research questions, hypotheses, and also objectives. And you have to sit down and then design your laboratory experiment to prove your hypothesis. In basic biomedical science, we always do laboratory experiment to prove whether our hypothesis is right or wrong, is correct or not. And actually, this is the good learning process, because the best way of learning is to do or to experience. It's not just reading. So doing a lab is what to do. It's the thing that you do it by yourself. You learn it from doing trial and errors. And finally, you get a skill. I always tell my students that doing a lab is not just LAB, because there's a meaning in there. L is mean labor, because doing a lab work is very labor jobs. It's labor work. You need to put a lot of energies, lots of effort, a lot of time in that to get the work done. And it's not enough. It's not just only your hands to get the work done. You need to put your heart. You have to have attention. You have to have a mindset, a good mindset to do the job. You have to know what is the benefit if the job's done. You need to do its best, not just get it done. If it fails, you attempt to do it again until it's success. Yeah, you need hand, heart, and the last one is about B, which is brain. You need intellectuals. You need to read a lot of paper. You need to read a lot of other people's works. This is similar or different from your works. And how, when you get the data, how do you interpret the data to synthesize, to analyze, and make the new knowledge from your data, from your lab data, the result. And finally, you will get the proof answer when everything success. From hypothesis, you will get a thesis. which means this answer is already proved by my own hand by the laboratories experiments that I designed. So the thesis is mean writing. So after you got the answer, you need to writing up. And the last process is to publish it. Because if you discover something and you don't publish it, it means you do nothing. You have done nothing or do discover nothing. So this is the most important part and also the difficult part too. After you got the data, you have to writing up the thesis or the manuscript. You draft it up and then you send it to your co-author to read it, to review it and edit it, and until you get the final draft and be ready for submission to the journals. You need to select the good journal that appropriate for your work. It depends on the audience because different journal have different audience or different reader. You have to decide what kind of audience, what type of audience that you want to communicate it with your data or with your findings. When you decide to select the journals and then you submit it, and then you they will take a consideration of your data, of your work, whether they're gonna reject it or accept it to publish. So this process is quite painful process because normally it's very rare that you submit to one journal and then they will accept your work to publish it. In my experience, I got a lot of rejection. So you have to be very good tolerance with it, rejection. Every rejection will discourage you, but you have to have a positive way of thinking to try more and more until some journal will see the very good thing in your manuscript or very good finding, and that's matched to that journals. And then they will ask you to revise it. After revisions, if they're satisfied with the revisions, then finally they will accept your paper or your manuscript, and then your work can be published. So this process is very take time. You have to be patient, have a positive thinking ways, because you're going to get a lot of rejection. The most difficult paper that I published, I got rejected about 7 or 8 times. Yeah, it is hard and it's hurt a lot, but we have to get through it. Before I end my talk, I would like to touch a little bit about the structure of manuscript. So we don't have enough time to go into the detail of each of it. So I just want to highlight some of them based on my own experience. For example, this is the whole paper or the whole manuscript. It's composed of this. We always start with the titles. And the title of manuscript has to be short, very specific, and catchy. After the title, you will see the author and affiliation, put all author that related to the work. And the next section is abstract. It's very important because you need to summarize and make in a concise way to tell people what your paper about. Normally, the length of the abstract will be about 200 to 300 words, but I would recommend you to make it about 200 to 250 because most of journals accept the length of the abstract around here, 200 to 250. The next part is my favorite part because introduction is it's important because you need to write a very nice way to convince people to believe that why is your research question is important. What is your finding contributed to the field? It is quite hard and you have to make a very good story to convince people. The next one is, I think the easiest part is material and method because you've done the lab yourself, so you know how to get that thing done. So you just write what you have done. After material and method is a result section. And this section is very important too because it give you a guideline to make a story. To me, I write the result section first in every manuscript. because I want to gather or to collect all the data I have. And I have to consider which data should be presented in table, which data should be presented in figures. And I have to make the layout from the beginning to the end. What is the table one, figure one, until the last figure. And then I'm gonna have the whole story and I make the story. It's like making a movie. You need to have a story and what is the opening line and what is the ending line should be, and who is the main character. Yeah, it's something like that, making the whole story. So I always take a look at the result and make the outline of the data first, and to complete the story. And after that, the next section is discussion. And to write the good discussion, you need to read a lot of papers. Which papers or which study that's related to your work, which one is similar or which one is different. You have to discuss why it's different, why is your data important, what it mean of your findings. The next after discussion is conclusion. This is also very important. I would like to suggest you to follow 3R rule for writing the conclusions. I always write this 3R rule in my papers. The first R is restate. You have to restate or tell again what is your key finding, the main finding, the novel finding that you have in your study. And the second R is recap. You have to tell the audience again what is that finding, that key finding of yours means. You have to give a little bit of interpretations on that. And the third R is recommendation. You have to tell the benefit, the clinical benefit of that. What is the clinical applications, or how much your data or your finding contributed to the field. Yeah, this is important for the 3R rule for me. I will use it to write the conclusions. After conclusion, you'll be acknowledged, and you have to acknowledge every people who contribute to help you to do the study, also the funding agency or who give you the money to do the job, do the work. The last one would be a reference. Yeah, reference difference between journals. You have to consult or you have to read nicely the author in instruction or the instruction of two authors. You will see the format of reference because different journals have different format. You have to follow them. And there's a software that helps you to do a reference. We call EndNote software. I would recommend you to learn and use the EndNote for the reference writings. And the important thing that I would like to highlight about writing up the manuscript or paper, yes, the first thing is about plagiarism. Do not copy anyone, even yourself. You have to write everything on your own, by your own way. Don't copy, don't do copies. The next thing is about the data or the finding. You have to be honest to present the real data. Don't falsify, don't make up the data. Don't manipulate the data at all. And the last thing is about interpretation or extrapolation. When you want to interpret the data, just interpret, just as it is. Don't over-interpret it, don't over-interpret the data. For example, you said your finding is in preclinical model. This drug worked very well in preclinical model. You can't say that it worked well too in humans. If you want to say that in humans, you need to do a clinical trial, for examples. That's sort of my talk that I would like to share with you about the step to get through from the beginnings of doing a research to the end to publish your data. Like I said, it's going to be like climbing up the mountain. You need to go to the top. I think it's not very impossible thing to do. If you can do it, I believe that you can do it too. If you think this is too many steps and too difficult, you have to change the way of how you look at it. You change the way, you change your mindset from fixed mindset to be growth mindset. Everything's possible. So when you look at the word again, If you see impossible, you change your mindset, the way of looking at it, and then you can see the word impossible. Yeah, you can do it. It's possible. But once when you get it successfully and you go to the top of the mountain, the real thing that you're gonna see, you will see when you see from the top view, you will see a lot more mountain, a lot more hill waiting for you to climb. So you need to ask yourself again, whether it's doing a research is a fun job for you. This is the real thing for you. If the answer is yes, yes, go further to climb up another mountain. But I can guarantee you that when you climb up another mountain, it will be much easier because you already have experience. You know the trick and you know how to do it. Yeah, and it will be easier. Or you can climb even the higher mountain later on. Yeah, I hope my experience would somehow help you. Yeah, I would like to have any question if you may have, or if you want to get in touch, it will be very welcome. Thank you very much. Bye bye.